Alright, jumping into 5.3. Got a couple new players in the game today. So we've dealt with perpendicular bisectors, and we learned that they created a spot called the circumcenter. And then we moved on to angle bisectors, which their point of concurrency, or where they cross, is called the incenter. And both of those two had some special properties, and the same is going to hold true for today. So let's just jump right in. We have medians and altitudes. So basically a median, and we start off by defining it right here. But a median is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So for instance, if we have this triangle here and I want to draw a median, what I have to do is I have to start at a vertex, and then I need to travel to the middle of the other side. So I find this midpoint and I mark it to show that it's in the middle, and this point right here would be considered a median. Now if I keep going around the triangle, if I go to this vertex and then to the middle of the side across from it, which would be over here, I would have another median. And then the third median would go from this corner to the middle of the opposite side, and I will end up with my third median. Now I didn't really talk about this in the previous notes, but this point where they all meet, we've been giving it names, and I've called it the circumcenter, the incenter, but in general that is called a point of concurrency. Point of concurrency is just a point where three or more lines cross, but the point of concurrency here is the medians create a point called the centroid. Alright, so this is our big word today, the centroid. Now, yesterday we learned that the circumcenter was equal distance from the vertices, or from the corners. We learned that the incenter was equal distance from the walls or the sides of the triangle. This point's pretty special itself, and down here if you kind of look below, it says the centroid is always inside, so it's always going to be on the inside of the triangle. And it's also called, and this is important in physics, it's also called the center of gravity. So the centroid it's the balancing point. It's where if I wanted to cut that out of metal and put it on my finger, I could spin it right around that centroid. Now there's also a couple other little pieces here that are true, and I'm going to scroll down to get into the Centroid Theorem. And the theorem, it's written a little bit weird compared to how I like to do it, but it says the centroid of a triangle is located 2/3 of the distance from the vertex to the midpoint. So for instance, if I focus on, let's just say this median right here, if I focus on AY, well, the centroid is at a certain spot that, regardless of however long these two pieces are, they always have the same relationship, in that this piece is going to be twice as long as the small piece over here. So if we call the small piece X, this piece is going to be 2X. It's going to be twice as big. So for instance, if we use numbers, for instance, if this little guy was 5, that would be 10. And I can go around the triangle, maybe this little piece here is 4, this one up here would be 8. And if this piece over here is 6, then this piece over here is 12. So there's always that 2-to-1 ratio. 2-to-1 ratio when you're looking at the pieces. I think this 2/3 kind of gets a little bit confusing. It's saying the same thing, but you're basically, one piece is twice as long as the other. I think in the examples this will hopefully become a little bit more clear. So let's look at our picture here, and I'm going to zoom, make this guy a little bit bigger just so I can draw on it easier on this big board. But it says in triangle LMN, RL is 21, so that means the entire length of this line from R to L is 21. And SQ is 4, so that's a different piece, is 4. Find LS. Well, the 4 was kind of threw me off and didn't really tell me much of anything. If this little piece is 4 though, if that piece is 4, the longer side would be 8 because there's a 2-to-1 ratio for every median. Now this one is kind of tough because they don't give me either the small or the large piece. But they do tell me the whole thing is 21. So what I need to do is I need to break that 21 up into 3 pieces. And I get 7 for the small piece, which using the theorem, the large piece should now be double that. It should be 14. So again, there's always that 2-to-1 ratio. Moving over here to the next problem, I'll kind of slide this over and scale him down a little bit. And moving over there to that problem, it says ZW is 7. So where's ZW? ZW is this piece right here. If that piece is 7 and L to X is 8.1, so L to X is a totally different median. So LX is the blue median, and we're going to make ZW, this is going to be the red median. So for the red median, I have a short piece, the 7, which means the long piece would be 14. All right, so they actually wanted me to know how far it was from K to W. So from K all the way to W, that's 14 plus 7. That's going to equal 21. If I look on the other piece, they really didn't tell me a whole lot. They told me that the total distance from L to X was 8.1. If I divide that by 3, 3 goes in there, 2.7. So I actually could find out the blue distances there. The small one is 2.7 and the large one is double that. It's 5.4. So basically, if you give me the small piece, I can double it and get the large one. If you give me the large piece, I can cut it in half and get the small one. The hardest one is when you give me the whole thing, I have to divide it into 3 equal pieces. So that's what you need to know about the centroid. Center of gravity, 2-to-1 ratio. All right, and altitude. And altitude is basically the height of a triangle. So when I have a normal triangle such as this, and altitude, basically it's perpendicular. It goes from the vertex to the opposite side. So a median went from the vertex to the middle of the opposite side. I don't want to go to the middle. I just got to get to the opposite side at 90 degrees. So that blue line right there would be an altitude. Now some triangles, if you're a right triangle, getting from the vertex to the other side at 90 degrees is actually one side of the triangle. So an altitude could be the side of the triangle, but it could be on the inside of the triangle and not even part of it. An altitude could also be on the outside. For instance, if we have an obtuse triangle here and I need to get from this point to the other side at 90 degrees, well, I can't do it right now. What I'm going to have to do is I'm going to have to draw an auxiliary line and extend that out a little bit. And now I can draw a line coming down. So sometimes the altitude is on the outside of the triangle. But an altitude is basically a perpendicular segment that goes from a corner to the opposite side at 90 degrees. Now, the point where they all meet is called the orthocenter. One thing I want you to remember about this one is orthocenter has no special powers. There is nothing special about the orthocenter. So you don't really have to worry a whole lot about that. Let's see if we can knock out this last example combining what we've learned today. So looking at the drawing, to me, when I look at these lines and I look at GL, okay, GL is a median because I see that it goes to the middle. Because of these marks, I see that it was a midpoint and it goes to the middle of the other side. Now it is also also looks like it's perpendicular, so it's also an altitude. So it's both an altitude and a median. Now when I look at HM, HM goes from the vertex to the other side, and since it goes right in the middle, that one is actually also a median. not HL, but HM is a median. And it looks like KJ, so I'm kind of looking at who created these things. KJ is also a median. All right, so we have three medians going on here. So I know the point that they meet at is called the centroid. So P is the centroid for this one. And now I got to try to figure out and get some numbers here. So let's see, the distance from G to L. Well, if this piece is 8, that means the small piece over here should be half of that, should be 4. So that would make G to L 12. I need H to L. Well, H to L, since this side is 5, that means this side is 5 because they're marked that they're congruent. So that should be 5. Distance from P to L I already got. That was 4. Alright, so now trying to figure out G to J. I think I'm going to have to use a little Pythagorean theorem here. If I look at this, GJ is this line right here. And looking at what I have so far, I believe I have a right triangle. I'm going to just kind of come out here. I'm going to kind of blow that thing up. And so I have a leg of 5. I have a leg of 12. And so trying to find GJ, I believe that's a hypotenuse. So I think I can use the Pythagorean theorem. And I can go 5 squared plus 12 squared equals x squared. And when I take the square root of both sides, I believe that's the square root of 169, which comes out to be 13. So GJ, that whole side is 13. So now looking for the perimeter, I can add up all three sides. This side of the triangle is 10, 5 plus 5. This side is 14 and a half. And putting all three of those together, that would be 37.5 for the perimeter. And the area, we're going to hold off on the area. I will do the area in class with you tomorrow. All right, see you tomorrow.